Hello, Honors Algebra students. Mr. Lawrence here, and we are going to learn a new way to solve quadratics. The first way we learned was factoring quite a long time ago. This one we're doing now is related to factoring. The second way was using the quadratic equation. Remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But we're actually going to learn a way that might be easier in some ways. It's called completing the square. And if you remember way back to factoring, we had these special factoring types. One was called a perfect square trinomial. When the first term and the third term were both perfect squares, and I took the square roots of them, so the square root of x squared was x, and the square root of 9 was 3. If I multiplied that together, the square roots, and doubled it, and I got the middle term, this was a perfect square trinomial, and it would factor real easy. It would be x plus 3 quantity squared, right? Remember doing that? It's been a little while. Now the cool thing is, I could solve this by listening to Saddam. See, I've got an exponent here. I could undo the exponent with the root. Of course, I have to do it on the other side, and then I would get x plus 3 equals 0, and then I could subtract 3 from both sides. And so I'd end up with x equals negative 3. What we're going to do with completing the square is we're going to have a trinomial that's not a perfect square trinomial, and we're going to turn it into one. Yeah, it's actually pretty easy. It's kind of cool that you can manipulate the equations this way. All right, so let's take a look at number 1 here. Oops, I don't think I gave myself enough room to work. Let me move that out of the way. Better give myself even a little bit more room there. All right, Control G, there we go. And that way I should have enough room to show all of my work. Okay, here we go. Now, right now, this is not a perfect square trinomial. I know that 7 is not a perfect square. First thing I'm going to do is I'm going to get rid of this c term. I'm going to add it to both sides. Okay. And I'm going to do something a little bit different here. You've never seen me do this. I'm going to go x squared plus 4x. I'm going to put, oops, I said 4x. I'm going to put plus a blank right there. And then on the other side, I'm going to do 7 plus a blank. You know, if I do it to one side, I have to do it to the other. On the left side, I added 7. On the right side, I had to add 7. Well, I added a blank. I'm going to add a blank. Now we're going to fill in this blank. And it's really easy to fill in this blank. You take half of b, and then square it. So half of b would be 2, and then 2 squared would be 4. I'm going to add 4 to both sides. Now what I've just done is turn the left-hand side into a perfect square trinomial. Yeah, it's going to factor as x plus what I got when I did half of b. Yep, what I did when I got half of b. Right, it's x plus 2 quantity squared. That's going to equal 11. Now, to undo the exponent, I'm going to use the root, but I have to do it to both sides, right? And so I'm going to get x plus 2 on the left-hand side, and the right-hand side is going to be plus or minus the square root of 11. Then I'm going to subtract 2 from both sides, and I'll get x equals negative 2 plus or minus the square root of 11. And you see I have two answers. Now if I want to go to a calculator on that, where is my calculator? Oh, calculator, here you come. Oh, it's just loading for the first time, no problem. Go ahead, talk amongst yourselves. Oh, never mind, came up right away. All right, so I've got negative 2 plus the square root of 11, which is approximately 1 in 32 hundredths. I'm going to round to the nearest hundredth place. I know it's only a rounded answer. So what did I say? 1 in 32 hundredths. So I'm going to get x is approximately equal to 1 in 32 hundredths. And notice I use the wavy equals because it's not really that. This is what we would call the exact answer right here. But that's difficult to graph. This is a little bit easier to graph, but it's not exactly right. So we use the wavy equal sign. Okay, now there's also a second answer. This is going to have two roots, and I better go back to my calculator for this. And I love using the second enter function because then I can just edit. And I need to do negative 2 minus the square root of 11 Uh-oh, I have an error. Let's go to it and see what happened. Oh, for some reason I lost my 2. Okay. That's what I want to type in. And when I do that, I get negative 5 and 32 hundredths. Negative 5 and 32 hundredths. So we just solved this quadratic equation. We didn't use the quadratic formula. We used a form of factoring. We made the problem become a perfect square trinomial. Now, one thing I need to let you know is that a must equal 1 for this to work. A must equal 1. Okay? So let's see. We're going to add 3 to both sides, right? That's the first step. And so now we have x squared plus 5x plus blank equals 3 plus blank. Now some of you are going to get freaked out here, man. Don't go to a decimal on this. Don't go to a decimal. We need half of b, right? Which is 5 over 2. Now I'm going to square that. When I square it, I'm going to get 25 fourths. Okay, so I'm going to need a 25 fourths over there. So the left-hand side is now a perfect square trinomial. It's going to factor as x plus 5 over 2 quantity squared. Now the right-hand side, I'm going to rewrite 3 as 12ths, and I'm going as a fourth, excuse me, and I believe that's going to be 12 fourths plus 25 fourths. And you'll see why I'm doing this in a minute. So x plus 5 over 2 quantity squared is going to equal 37 fourths. Okay, and now I'm getting ready to take the square root of both sides. So I'm going to take the square root, take the square root. Now the left-hand side simply becomes x plus 5 over 2, or 2.5. And this is going to become plus or minus the square root of 37. Oops, not of 7, 37, excuse me. There we go. 37 over 2. Where did I get the 2 from? Well, this is the same as the square root of 37 over the square root of 4, and the square root of 4 is 2, right? The positive square root. So that's where I'm at right now. It's starting to look a little bit like a quadratic equation answer, isn't it? Yeah, it sure is. I'm going to give myself a little bit more room here. Let me erase that stuff. Okay, so now I'm going to subtract 5 over 2 minus 5 over 2. Notice I didn't go to 2.5. It's going to be a lot easier if I don't. X is going to equal negative 5 over 2 plus or minus square root of 37 over 2. Since they have the same denominator, I can write it as one fraction, negative 5 plus or minus square root of 37 over 2. Wow, that looks like something we get out of the quadratic equation, or the quadratic formula. So let's go and get my decimal approximations for these answers. Hold on a second, having a little technical difficulty. All right, so let me put a little mark down here so that doesn't automatically. So negative 5 plus square root of 37 divided by 2. Okay, there's my calculator. So I'm going to put my numerator in parentheses. I'm going to go negative 5 plus the square root of 37. Oops, I didn't get the square root in there, did I? Sorry. Second. Nope, doesn't like that. I'm just going to start over and go with negative 5 plus the square root of 37. Get out of there. Close that quantity. And I'm going to divide by, oh, I forgot. What am I dividing by? 2, I believe. Yeah, 2. Oh, not decimal points, silly me. Okay, and so we get a decimal approximation of, hold on a second here, about 0 and 54 hundredths. All right, so one of the answers will be 0 and 54 hundredths, and then we have to find the other one, and we can do that real easy. We will just do second enter, and then go back and change that. Plus square root of 37 to 1 minus the square root of 37. And there we go. So we get negative 5 and 54 hundredths. All right, so we're going to get, oops, I'm not in draw mode. There I am. negative 5 and 54 hundredths. And there you go. All right, one last one, and then we'll call it quits on this video. No video quiz on this one. Okay, remember before the last problem, I said A had to be equal to 1. In this problem, A is not equal to 1. So I'm going to divide everything by 3 because that will allow A to become 1. And so when I do that, I'll get x squared plus 7/3 x minus 3 equals 0. I'm going to add 3 to both sides. Then I'm going to get x squared plus 7/3 x plus blank equals 3 plus blank. Now I take half of 7/3. Well, wouldn't that be 7/6, right? Half of 7/3, and I square it. And I'm going to get 49/36. So I'm going to add 49/36 to each side. And notice I'm not changing that to a mixed number or anything. I'm leaving it as is. So I'm going to factor the left-hand side as x plus 7/6 quantity squared. Excuse me a second. That day off after Friday did me a lot of good, but I'm still not 100%, but that's okay. Getting better every day. All right, so I need 3 with a denominator of 36. What am I thinking? 108 there, maybe? Oh, pardon me again. Yeah, I think that's right. 108. Okay, so I have 108 plus 49/36. So my denominator is going to be 36. My numerator is going to be 157, which I don't believe is a perfect square. I'll take the square root of each side to undo this exponent. Okay, if you want, you can just do it like that. You know, numerator and denominator. I'll get x plus 7/6 is going to equal plus or minus the square root of 157. It's going to be bigger than 12, but smaller than 13. Kind of close, maybe like 12.7-ish, 12 7/10 over 6, right? And so now I'll subtract 7/6 from both sides. And when I do that, I get negative 7 plus or minus square root of 157. And I'm going to put the whole thing over 6. Instead of writing the two fractions and then combining it, I'm just going to go right to one fraction. And at this point, I've got my exact answers. I can go to my calculator and get the two solutions now. And so I'm going to have negative 7 plus the square root of 157. Put that in parentheses. Dividing by, oh, I forgot what I'm dividing by, 6 this time. I'm dividing by 6. All right, dividing by 6. And there's my first, maybe. There's my first answer, about 92 hundredths. And then my second answer, I have to make that a minus square root of 157. And I'll get about negative 3 25 hundredths. All right, so there are your two answers. I'm not going to take the time to rewrite them. There they are right there. All right, so that's it for the video. To recap, what we did was we forced a trinomial to be a perfect square trinomial, right? Remember that on the first step, we made sure A was 1, and then we got rid of C. We moved it to the other side of the equation using either addition or subtraction. Then we take 1/2 of B, and then we square it. And when you do that, you force it to become a perfect square trinomial. And from there, it becomes very simple. All right, if you need to rewatch the video, go right ahead. We'll get some practice with this Tuesday and Wednesday in class. Mr. Lawrence signing off. Have a good night, everybody.